Last class, we saw the equation of circle in parametric form. Okay, what is in a parametric form? So we had these coordinates. Okay, we did for when the center is origin as well as it's not origin also, correct? We had this circle like this here, and this is 0 comma 0 is the origin, and we got the parametric form, correct? So suppose this is a point x comma y. So in a normal equation, what is the equation of a circle? Tell me. X square plus y square equal to r square, correct? Where r is the radius of the circle. So the r is radius. So in a parametric form, we will have theta. Am I right? Can you tell me what was that? X is equal to r cos theta and y equal to r sin theta. So this is the equation of the circle in the parametric form. Okay, what's the advantage of parametric form? See here, as you move all the points in the circle, they are going to have different x and y's. Correct? In the parametric form, all the points are of the same r. Only theta changes. Okay, so if either you can use circle, define the circle as x comma y or r comma theta. So I take theta when r with theta 0 to 2 pi, that is a circle. Okay, so that's a parametric form. We can do that. Okay, now today let us see about the tangent to a circle. So what is a tangent to a circle? Tell me. Do you know what the meaning of a tangent to a circle? Not perpendicular. Yeah, that will make a perpendicular. It touches at. Okay, I am not able to draw it exactly. So let this be the circle. Only one point. Okay, when the circle touches only at a one point. Sorry, when the line intersects the circle only through one point, then you call that line as a tangent. Okay, so you see, if I draw a line like this, so this line intersects at 2 points, correct? So if I keep moving at somewhere else, the line will touch at only one point. So that point is called as a tangent of a circle. So now we want to find out what is the equation of the tangent of the circle. Let us try to find out the equation of the tangent of the circle. Okay, so what we are going to do, so let us say, let us draw a tangent from a point on the circle, correct? So let this point be, what we will call this point, x1, y1. We will call this point as, this point as x1, comma y1. Okay, now I am asking, so the circle, there is a circle of radius r with origin at the center. What is the equation of this straight line? Okay, and it is very simple how to find out. I can, if I join these two, what will be this angle? 90 degree, correct? Because you know the property, right? Center of the circle intersects, the line joining the tangent, the point of intersection of tangent to the center will be 90 degree. So now you know this point and you know this point, that is x1, y1. Can you find the slope of this point, this line? If you know this slope, then you can find this slope also, because this minus product at 90 degree, yes, m1, m2 equal to minus 1. So you can find the slope of this line also. Now you know this line passes through this point. So now you know the point and the slope. So we get the answer. So let us be called this as slope of this line as m1 and the slope of this line as m2. Okay, so let us find out. Okay, we are going to first find slope m1. How will you find slope m1? We have 2 points, right? So, yes, m equal to y2 minus y1 divided by x2 minus x1. So, what is y2 here? y1 here, right? y1 minus 0 divided by x1 minus 0 equal to y1 by x1. Okay, so now we know that line. Let me put up a names. So O, let this be A, B, and let this point be P. Okay, AB is perpendicular to OP, correct? So this is the slope of OP. So slope, therefore, let the slope of AB be M2, correct? That's what you are given, M2. So now since AB is perpendicular to OP, we have M1, M2 equal to minus 1. So M1 we got, that is, so this says M2 equal to minus 1 by M1. That will be how much? Minus x1 by y1. So we got the slope. Now we want to find the equation of the tangent. Therefore, the equation of the tangent AB is, okay, yeah, tell me, what is the equation? Our equation is y, because one point we know and the slope we know. So we have done it already, right? Y minus y1 equal to m2 into x minus x1. So tell me, what is y minus y1 equal to m2 is how much? Minus x1 by y1 into x1 minus x minus x1, sorry. Minus x1, correct? What am I doing? Okay, good. So we will take the y that side. So then what happens? Tell me. So when you take this one, so this will become y1 minus y1 square equal to, this will be minus x1 plus x1 square. Okay, so let me take this x1 here. So it becomes y, okay, I can write it like in the form x1 plus y1 equal to x1 square plus y1 square. Can you tell me what is x1 square plus y1 square? Let us say, what is the radius?
R square cos.
Radius is what? OP, correct? So let us find radius square. So OP square will be equal to OP square, na? What it will be?
X minus 0 whole square plus y minus 0 whole square.
What is this?
X square plus y square.
X1 square plus y1 square. So that is the radius, correct? Let me call the radius as r. Therefore, this is r square. So therefore, this equation will become, therefore 1 becomes x1 plus y1 equal to r square. So this is the equation of the tangent. Is a straight line? No. A linear? Why it's not straight line? It is linear, na? X and y. Okay, there is no x square. So linear, na? X and y equal to r square. You can find out the slope and everything from this equation itself. Okay, so this is the equation of the tangent to a circle. Okay, so now the question is, okay, now we did it for at a center 0, 0. Now if the center is not 0, not at origin, how will you do that? If the center has some hk, shall you do? So what this will be? So let us see that. So now the circle is, we are having this coordinate system. That's also simple. So we have the circle somewhere else here, where the center is, let us call h comma k. Okay, and we are having a circle around it. So there is a circle around this hk, and then there is a tangent. Let us draw a tangent. Maybe I can draw a tangent something like this. Okay, and this point we call it as x1 comma y1, and let the radius be r. So how the way we do it? We call this as center C. This point is P, and let us take 2 points. This is A and this is B. So we need to find the equation of the tangent when the circle is having a center h comma k. The same way, correct? So how will we do first? What's the way we will proceed? Tell me.
We find the slope of PC.
Correct. Find the slope of PZ, and minus 1 upon that slope is the slope of the other line, and you know that line passes through that point. The same way you can find out the answer. Correct? Tell me. So what is slope of PZ? PC. That is what we will call it as M1. M1 and this is M2. M1. So what it will be? Tell me. M1 equal to Y1 minus H divided by
Y1 minus K.
Y1 minus K divided by X1 minus H. Keep it like this. So then, therefore, M2, what we have? We got M2. Okay, M2 equal to 1 upon M1, minus 1 upon M1. So it will be minus X1 minus H.
Plus. Okay, yeah.
Correct? Yeah. And Y1 minus K. Correct? So now we know the equation of the straight line of AB. Therefore, equation of AB will be what? We know one point. We know the slope. We know the formula. So that is what? Y minus Y1 will be equal to slope. Slope is what? Minus X1 minus H dot Y1 minus K into X minus X1. Tell me now what it is.
Y to the LHS.
Okay, so Y minus Y1 into Y minus K, Y1 minus K will be equal to
H minus X1.
okay, H, we are taking the sign inside, right? H minus X1 into X minus X1. Tell me what this will be. So this will be Y1, correct? Minus KY, KY
Minus Y square.
minus Y1 square
Plus Y1 K.
plus Y1K, correct? Here it will be Hx minus Hx1 minus X1x plus X1 square. Okay, so now we can do that here same way, correct?
We can take the Y to
Yeah, no, find out the radius. Let us find the radius. Radius is PC, that is equal to R, that will be how much? Or PC square I will call. That will be X1 minus H whole square plus Y1 minus K whole square. See, can we write from here anywhere else? Or you can open it, we'll get it an idea. So what this will be? Tell me. Oh, is there anything we can add up and all? No, right? Tell me what this is.
X1 square
X1 square plus H square minus 2x1h plus y1 square plus k square minus 2y1k. Okay, this will be r square. See, compare from here. So, okay, let me take out all these, y1 square, right? Let me take this y1 square here. So, what am I going to have here? y1 and let me take this one here plus x1 and let me take all the other terms in the right hand side. So, what you are going to get? X1 square plus y1 square. Okay, these two I took, and then what we have? Tell me what we have? Minus. Tell me.
minus H1 Hx1
Hx1 plus Hx, correct? I took all the three, and here
plus Ky
plus Ky
minus Y1K
minus y1k. What? So if I take x1 square, see, let us try to, what one way we are going to do, we have x1 square, y1 square, na? We will express it from here. So what we have, x1 square plus y1 square will be r square, correct? Take everything other side, minus y1 square minus k square Oops, sorry, minus r square. H square, sorry, yeah. Minus h square minus k square plus 2 hx1 plus 2 ky1. So let me substitute that here. So what we are going to get, tell me? R square minus h square minus k square plus 2 hx1 plus 2 ky1. Okay, and then here minus hx1 minus ky1 plus hx plus ky. Correct? So then what happens? Yeah, so this will come out, right? So then what will we have? So this will become, so this I'll write it here, r square minus h square minus k square. This will be what? Tell me? Plus hx1 plus ky1 plus hx plus ky. Now you can take this side, other side, right? Okay, so when we take the x and y other side, because we are x and y here, na? So when we take that, what happens? So when I take the y here, this become y1 minus k into y. Correct? So we'll get y1 minus k into y plus x1 minus h into x. Correct? Is that right? I have taken these two, that side. Here. So then here what is left over for us? Tell me. R square plus minus h square. Okay. So, oh, sorry, yeah. R square minus h square minus k square plus hx1 plus ky1. We can still proceed further. See, for example, if from here, if I can take h commonly outside, so what we are going to get? R square. So let us take, no, I will take minus. So minus h if I take outside, so become x1 minus h. Correct? And then from here, I think I missed something. Which was one? This is plus ky1, na? This is plus na here. Correct? Plus ky1. So I'm going to take minus k outside. So this will become y1 minus k.
K minus.
Check.
It should be k minus y.
This is plus ky1. Na? I'm taking it.
No, you are taking.
Oh, sorry. Plus. Are you sure we didn't do the mistake here? Yeah, ky1. So then why this one?
Oh, that also should be.
This also should be plus here. Correct? This also should be plus. Okay? Now correct? And still we can do some more jugglery. You can take these two things here. So what we are going to get? y1 minus k of y plus x1 minus h of x. If I take these two here, what are you going to get? Minus h x1 minus h minus k y1 minus k equal to r square. So then from here, I can take these two commonly outside. Correct?
X1 minus.
Yes. What you will have? x1 minus h x minus h plus y1 minus k into y minus k equal to r square. So this is the equation of the circle in general. Equation of a tangent. Tangent to a circle if the center of the circle is h cross k and the radius is r. Okay, at a point. So this is a way you can find the equation of a tangent to a circle. Okay, now the question is, can we find the equation in the, okay, so let us try to write in a general form. Last time we saw the general equation also, right? X square. So you remember what is the general form of a circle? What was that we did? Tell me.
Square plus y square.
Yeah. So let us say that x square plus y square
Plus 2g
gx
plus 2fy plus c.
equal to 0. And you know the condition, g square plus f square minus c should be greater than 0. That's the radius. Okay. So now, given this is a general equation of a circle, and now you have to tell me, so let me define this as your, this equation. This equation is the, which decides the circle. We never know, some center and all. Now, given this equation, what will be the tangent? Equation of the tangent. Okay, that is not given radius and all, right? We can do that similarly. Okay? So, how will you find the equation of the tangent to this circle at a point x1, y1? We can use the same formula. All you know is, you should know what is the radius. You know what is the radius. You know what is the center. Tell me. So, for given this circle, what will be the center? Center C will be?
Minus g comma minus f.
Minus g comma minus f. What will be the radius?
Root of g square plus.
Let us take radius square, r square, because we are having r square, na? R square will be what?
G square plus f square minus c.
Okay, so now you want to find out the equation of the straight line, tangent to the circle at a point x1, y1. Use this formula. If a given c center and radius is known, we can directly use this formula, correct? So tell me what is the formula? So x1 minus h, correct? So here it will be g plus g, correct? And x, correct? Tell me.
X plus g
Okay.
plus y1 plus f into y1 y plus f.
Okay. Equal to.
G square plus f square minus c.
So let us open it. So what this will be? Tell me.
X1 x
X1.
x1 gx1 plus gx plus g square
Plus g square.
plus y1 plus fy1 plus fy plus f square
Equal to.
g square plus f square minus c plus g square f square we cancel.
Yeah. What we have? G square plus f square minus c. Correct? So g square cancels. F square cancels. So now you tell me. What do we have? Tell me. So we are having x1 plus y1 plus gx plus gx1 plus fy plus fy1 plus c is equal to 0. This is the equation of the line. Okay, so and what they have taken is you can take g commonly outside. So when you do that, x1 plus y1 plus g, if you take x plus x1, and if you take f from here, y plus y1 plus c equal to 0. Okay. So actually, it's very easy way to remember this equation from the general equation of a circle and the tangent from a point
It's the
is.
same type, but x will be x.
Yes, exactly. Take 1x. So this is the equation of the tangent to the circle in a general form, correct? So there is the x square. There all the x's there, na? You would break up into this. I can write it as x into x plus y into y plus 2gx. I can write it as gx plus gx plus fy plus fy plus c equal to 0. Correct? take 1x as x1. So take this as x1, this as y1, then this as x1, and this as y1, and that's the answer. Okay? So that's the way we can find the equation of a tangent to a circle. Now one more thing we can do. One more thing is, what will be the, okay, tell me, what will be the equation in terms of a parametric form? When you are given the equation of the circle in parametric form. Parametric form is what? X is equal to r cos theta and y equal to r sin theta. So under that case, what will be your tangent? Okay, and that's very simple. How will you, should you want to do that? Okay, I can do it. Let us see. Let me do that. Okay, so what is that we are having? We are having this coordinate system. Okay, and we are having this circle. Okay, so and we are having a point, some point, say let it be x1 comma y1. So in a parametric form, this will be theta. Okay, so we shouldn't call theta, since it's x1 y1, this will be theta 1, some angle. Okay, some other point here, some other theta 2. But whereas the radius is going to be always same. So here what happens, so we have x1 equal to r cos theta 1 and y1 equal to r sin theta 1. Now can you tell me what will be the equation of the straight line? Yeah, okay, for a simplicity we are taking it as origin 0 comma 0. We can do it for general equation also. Okay, I am not going to do that. So we know if this is the condition, what is the equation of the circle we have? X square plus y square equal to r square. What is it? X square plus y square equal to r square. No, that's the equation of the circle. Yeah. I got it. I am saying equation of the tangent. Oh, tangent. Okay, sorry. I should have written there, not tangent. This is a tangent passing through the point. What is the equation of the tangent? We get x1 plus y1 equal to r square. Correct? So now we substitute for this x1.
xr cos 1.
R cos theta 1 plus y or sin theta 1 equal to r square.
We take the r commonly.
Okay, so tell me.
We take the r outside.
Okay, good. Take the r outside. So what do you have? X cos theta 1 plus y sin theta 1 equal to r. So this is the equation of the tangent in the parametric form. When you define your circle in the parametric equation, what you have done, the circle is given in the parametric form. So then what will be the tangent through a point? Tangent through a point which is r theta 1. This is the equation of the tangent. Cool? Okay. Now we will ask a question. Given a line y equal to mx plus c, the line I have drawn like this here, can this line be a tangent to a circle? Okay. So tangent to a circle means, okay, there can be one point x1, y1. Will this line be a tangent? Okay, this line can be any line, it may be somewhere else here. If it is here, it won't be a tangent. So time it should pass us through the point, right? So we have to find out whether this line, what is the condition this line should satisfy such that it can pass through, it can be a tangent to the circle. Now if you see, line with any slope can be a tangent to a circle. So if you remember this equation what we had, y equal to mx plus c, right? If you remember y equal to mx plus c when we see in the last chapter, okay, where m is the slope and what is c? C is the y-intercept, correct? So the circle can line with, the slope is this one, right? Any slope can be a tangent. So now what happened? So when the line touches at a circle at a one point, it will become a tangent. if I draw another parallel line, that won't be a tangent, but the slope will be same. It won't be a tangent. Similarly, I move it here, then it intersects us, it becomes at 2 points and this is not tangent. So then what is the deciding factor to say this line is a tangent to the circle is the y-intercept. Am I right? Am I right? So because I am going to maintain the same slope, if I move it above or below, it is not going to be tangent. So then what is going to change when I move above and below? Y-intercept, that is C is going to change. Okay, for this line, take any other line, maybe a line like this. Again, that's what I'm saying, line with any slope, because slope is what? With the angle, na? That we remember the way how we took the angle, tan of that angle with the slope. Okay, so any line of all possible slopes, we can have, it can be a tangent to the circle, provided the y-intercept satisfies certain condition. If I want to draw a tangent at this point, so then see something like this. So then this is the y-intercept. So the moment I can have another parallel line, then the y-intercept is going to be different. Then it is not be a slope. So why I am telling you this is, so a line is tangent to a circle or not, the condition should come in your y-intercept. That means what is the y-intercept? C. So the C should satisfy certain condition. Then only can say the line is a tangent. So let us see. So how we are going to do? So we given this is the equation of the circle. X square plus y square equal to r square. This is the tangent. Okay. So we know in general, tangent to a circle. What is the equation? X(x1) plus y(y1) equal to r square. So our given line is what? Y equal to mx plus c. Let us, so this is 1, this is 2. So we are saying this line has to be a tangent, right? So then both has to be same. So let us write both in the equivalent form. So this 1, we can write it as, how can we write 1? So y(y1) equal to r square minus x(x1). Or y equal to, tell me, r square by y1 minus x1 by y1 times x. Correct? So now let me call this as 3. Compare 2 and 3. They both are same. And 3. So then we can equate the coefficients. The slope should be equal to, m will be equal to, because x, na? So there will be minus x1 by y1 and y-intercept, right? C will be equal to r square by y1. So this will give me y1, correct? So okay, for example, here I am going to get my x1 will be minus m y1. Am I right? Is that correct? And so this is going to give me y1 equal to r square by c. So let us substitute this y1 here. So what will have x1 equal to, tell me na,
R square by
minus mr square by c. Therefore, okay, so therefore the point x1 comma y1 will be equal to minus mr square by c comma r square by c. Okay, so if this line, we are not at proved, okay, if this line would have been a tangent, so this is the point of intersection. So we got, so first we have to prove also, before we, though we got this point of intersection, we have to first make sure this line is a tangent. Okay, so this point, so x1 comma y1 lies on the circle. So it should satisfy the equation of the circle. So then we have, what is the equation of the circle? X square plus y square equal to r square. So therefore what means x1 square plus y1 square equal to r square? Tell me now, substitute what is x1 and y1. Tell me.
x1 is equal to minus m square r to the power 4 by c square plus r to the power 4 by c square.
Okay, equal to
R square.
r square. So now this r square cancels off, become 2. Become 2. So then what is the answer we are getting? So m square r square. I'll take an c square out this side, correct? So we are having m square r square plus r square equal to c square, or c square equal to r square into 1 plus m square. So what is c? That is a y-intercept, correct? So then we can have c is equal to plus or minus r square root of r square into 1 plus m square, correct? So how many c intercepts you are getting? 2. Is that correct? Because if a line with the same slope, there can be one tangent here. You keep moving down. This is another line, correct? So this is another y-intercept. So we have actually 2 y-intercepts. So you can see one actually goes positive, one goes negative. If it is center is at 0, remember, only when your center is at 0, 0. If it is somewhere else, then that won't be positive, negative. Okay, so this is the condition which tells if given a line y equal to mx plus c, if I ask a question, if a line y equal to mx plus c, if it want to satisfy the satisfies a tangent to this circle, x square plus y square equal to r square, the condition is this. Then the c should be equal to the radius square into 1 plus the slope square. If this condition is satisfied, then the line can be a tangent to the circle. And what is the point of intersection? Point of intersection is here. Correct? The point of intersection is here. Okay, and that's it. So since you have two y-intercepts, for a line with the same slope, there can be 2 tangents. Okay? Now we will ask another question. Given a point, say earlier we said the point is on the circle, correct? The line which is a tangent to a second intersection point and all. I am giving you a point outside the circle. Say it is x1, y1. Now you have to find out, can we draw a tangent from that point to a circle? We want to find what should be the equation of the circle. Okay, so now to get this, so what is the equation of the tangent, the straight line? Okay, to get the equation of the straight line, what you need to know is, we know one point. If you know the slope of it, then you know. If you have one point and one slope, then you know the equation of the straight line. Y minus y1 equal to m into x minus x1. So we have to basically identify the slope of this equation. Okay, so how we are going to find the slope? Okay, so let us say, for example, this is the point. Okay, and let this line be written as y equal to mx plus c. I don't want to write that as y equal to mx plus c. So let us have it like this. So this is a line. Okay. Now, okay. Tell me. Okay, let us have that. Tell me what should be the. Okay. Yeah. Let me have it as. Let the slope of this line be m. We will write it out. Okay. So then, if I give you the slope of this line, then you can find out what's the equation of the straight line. Y minus y1 equal to m into x minus x1. Correct? This is our slope. So now I am asking you the question. Okay. So what is the distance of this line from the center? That should be the radius. Correct? Because this is a perpendicular distance. So this distance should be the radius. So we know you have found the formula, the distance of a straight line from the origin. What is that? If your given line is ax plus by plus c equal to 0, the distance p from the origin will be c divided by root of a square plus b square. And here the mod, because distance is always positive. Correct? So let us try to find out. So again we are given this line. What's the distance of this line from the origin? So basically we want to write the line in this form. Correct? So we will have. So let us first write the line in this form. So what happened? Let us take the x, y and the constant terms. So let us open it up. Y minus y1 equal to mx minus mx1. Am I clear? So let us take everything this side. So we have mx minus y, correct, plus y1 minus mx1 equal to 0. So this is the constant term, see here, correct. So this corresponds to your, so if I compare this equation, so this is your A and this minus 1 is B and this whole term is your C, correct. So, and then, so therefore, the distance, so this will be, let the line be 1. Distance of 1 from the origin. Do you know what we are trying to do? I think, what we are trying to do, we are trying to slope of it, huh? Remember that. So from the origin, what is the line from the origin? So that should be radius r, and that is here r, radius, that should be equal to mod of, so here it is c, right? What do we see here? y1 minus mx1 divided by a square plus b square. A square is what? M square, and b square is minus, b is minus 1, b square is 1. So this will be 1 plus m square. Correct? So now it's a mod. So if you want to remove the mod, what will you do? Square it. Am I right? If you square it, the mod means can be positive or negative. If I square, it's going to be positive. Correct? So well, let me square it. R square will be equal to y1 minus mx1 whole square, and the square root goes off 1 plus m square. So when I take it here, what we are going to get, tell me? R square plus r square m square equal to y1 square. Tell me. Plus?
Minus. Oh, sorry. M square x1.
Then minus 2 m x1 y1. Let us write in the quadratic equation form. Because we want to find out slope. Remember, our aim is to find the slope. Okay, once if I find the slope, the equation is known. We have to find out what does m is. So we are trying to do. So what will happen? So let us take m square term. I am going to write x1 square m square, and okay. Let us write it. Let us take everything that side. Okay. So what we are going to have, y1 square plus m square x1 square minus 2m x1 y1 minus r square m square equal to 0. Correct? Let us take the m square term commonly outside. So we are getting x1 square minus r square. Is that correct? Into m square. Tell me, what is that? And now tell me, what is the m term?
Minus 2m.
Minus 2 x1 y1 m.
Okay. Plus y square, y1 square.
Plus y1 square. Minus r square. Are you sure anything left over?
No.
Correct? So now you can actually find out. Now you can find the slope of it, right? So what will be your m? Is a quadratic equation in m. So m equal to minus b, that is 2x1 y1. Because we are ax square plus bx plus c equal to 0. So x is equal to minus b plus minus root of b square minus 4ac 2a. Okay. So do this one. So minus b, that is 2x1 y1 plus b square, that is 4. Tell me, 4 plus minus 4x1 square y1 square.
Minus.
Tell me.
Minus 4 times x1 square minus r square into y1 square minus r square.
y1 square minus
R square.
r square divided by
2a.
2a. 2a is what?
2 times x1 square minus r square.
Okay?
Huh.
If you take 4 commonly outside, this becomes 2.
Huh.
Okay? Because square root of 4 is 2. All these 2 will cancel. So m will be equal to. So m is equal to, tell me, x1 y1 plus minus root of x1 square y1 square minus x1 square minus r square into y1 square minus r square, okay, divided by x1 square minus r square. I think we can still do something, because this, if we open up the next one square, y1 square will get cancelled. Am I right? Shall we try that?
Okay.
Tell me what it will be. So let us take the root one. Let us try to find out this one. So only this one I am writing. So let us open up this one. So what will you have? x1 square y1 square
Minus x1 square y1 square.
no, oh, no, this one na
Minus x1 square y1 square. Wait.
minus, yeah, I am not taking the minus, I will take the minus outside later on. So then plus minus r square x1 square minus r square y1 square plus r power 4.
Okay.
Correct? So when we do that, correct, yeah, we can do that. So then what happens? So this will be equal to x1 y1 plus or minus root of x1 square y1 square minus this one, correct? x1 square y1 square, tell me what is that?
Minus r square x1 square minus r square
y1 square
plus r is to the power of 4.
plus r to the power of 4. Is that correct? Yeah, and divided by
x1 square minus r1 square.
x1 square minus r1 square.
R square.
So-
R square, R square.
R square, correct. So this cancels off. So this, when you take minus, this becomes plus.
You can take the r square outside.
Yeah. So if I take the r square commonly outside, so that I can take the r also outside. Okay. So what will we get? So finally, where will I will remove this one. So finally, what will we get? So our m will be x1 y1 plus or minus r into root of. So this is minus now and become plus. R square, no, R square won't be there.
x1 square
x1 square plus y1 square minus r square divided by
x1 square
minus r square. So this is the slope of the tangent. Okay, this is the slope of the tangent which passes through the point x1, y1. How many tangents?
1. No, 2.
2 tangents. Why? Because one is plus and another one corresponds to minus. Yes, of course, we'll have 2 tangents because from the exterior point, you can actually draw 2 lines. 2 tangents to a point. Okay. So, and suppose I'm giving you a, okay, so then let us have another question. There's something called as, what they call it as a director circle. What is director circle is? That is simple. So what am I going to do? Let me have this tangent here. Okay. So now, I am going to, you have a tangent. Okay. So this is a tangent I have drawn with a slope m and maybe a point here, an external point, whatever. Can you draw a line perpendicular to this line, which should be again a tangent to that. Can we draw? Something like this, right? So if we draw it like this, I will call this as perpendicular. Okay. Then I can have another one line also, tangent. Something like this. Okay, this is another line. And again, I can have a line, another tangent which is perpendicular to this tangent, but it's still again like this. Then I can draw another one. Say something like, I can keep on drawing, right? So let me draw it like this here. So now then I have to have another, this actually there are two lines can be drawn. Here as well as here. Am I right? So similarly I can keep on drawing. So then what happened? You can actually get lot of points. So finally what you will have? You will have what? Tell me. A circle. So what is the condition? What will be the condition of the circle? From that circle, if you draw any point, you can draw two tangents. That's what we saw from here. The two tangents, the slope of the two tangents will be, product will be minus 1 because they are perpendicular to each other. Okay, so that circle is called as your director circle. Okay, what the definition here they get? The locus of the point of intersection of perpendicular tangents to a circle. Okay, this is a perpendicular tangent circle, the locus of this point. Okay, I can keep moving this point. Everywhere I can always write 2. So when I put it here, I'll get these two tangents. I keep moving, I can always draw a circle. Only thing is the tangents drawn from the point should be perpendicular to each other. Okay, so this is the director circle. Okay. Let us find the equation of the director circle. So if you remember the earlier calculation, given a point, given external point, what we did, we draw a tangent to a circle, correct? So, and then what we got the quadratic equation in slope. Am I right? Can you tell me what was the quadratic equation we got in slope? What is that we got? If you remember what I wrote is, we have, if I take the external point is x1, y1. Okay, then we get x1 minus r whole square m square minus 2x1 y1 m plus y1 square minus r square equal to 0. Correct? Okay, so if you remember, we had this quadratic equation. If you have this equation, ax square plus bx plus c equal to 0. It has two roots. If you remember, then we have, suppose x1 and x2. x1 and x2 are the roots. Then we had a formula, x1 into x2 equal to what? x1 plus x2. Do you remember? What is that?
x1 into x2 equal to c by a.
Correct. Perfect. You are right. x1 into x2 equal to c by a, and this will be minus b by a, I think so, right? Minus or b by a, something like that, right? Yes. Minus b by a. Correct? Minus b by a. Yeah, right. Okay, minus b by a. So we can use directly that formula. That makes it easier. So we have this relation here. So let us try to, okay. So let us try to see what is, when I compare with this, so this is our A and this is our B and this is our C. Okay, so let us from there we can find out what is the sum, because product of the roots. So we have the two solutions, right? M1 and M2 be the solutions of this quadratic equation. So what will be M1, M2? Tell me. M1, M2 equal to C by A, correct? C is here. Y1 square minus R square by A is X1 square minus r square. Now for a director circle, this will be equal to what?
-1.
Minus 1. Okay, and that's what that's it. This is the equation of the director circle. So what will have y1 square minus r square equal to minus x1 square
Plus R.
plus r square.
So we can take the x1 square, let's say R
Yes. So what happens? So x1 square
plus y1
plus y1 square
equals to 2R.
2r square. So this is the equation of a director circle to a circle. Correct? Director circle will be always for another circle. Director circle for this is the for the circle. What is the circle equation?
X square,
Tell me. Correct.
x square plus y square
X square plus y square
equal to R square.
r square. So that's it. Okay. There's only one thing you should be very cautious here. What should be cautious? x1 and y1. They are not a point now. Okay, that point, that can be any points here. So that's a director circle. Okay, so earlier we said a point. So we are writing it as x1, y1. Because I can't write x square, y square. You can write also x square, y square equal to 2r square. So that means this is a circle. Okay, so when you okay, you can write that way also. Yeah, we can write that way also. So x square plus y square equal to 2r square. So if I given any circle, x square plus y square equal to a square, the director circle of the circle will be x square plus y square equal to 2a square. As simple as that. Okay, so this is the way your circle and its director circle. Okay, so can you tell me what is the radius of the director circle?
Wait, sorry. Half of no.
What is the radius? Suppose if A, this is a radius square. So if this is the radius of the circle, radius of director circle will be
1 by root 2.
1 by root 2. It's square root of A. Correct? This is the radius, na? Okay, so this is r square. So suppose director circle radius is r square equal to 2a square, where a square is the original circle. So r equal to what? Root of 2a. Correct? Okay, and that's all we have. So now we have to do all the exercises, examples and exercises, and next time we will see any problems if you are not able to solve. Okay?